2. So first of all, that node there is like, it represents like you. It could be anybody, it could be a company, it could be a person who's trying to make a decision, it could be an entity, anything. So that person, an entity is trying to make, let's say for example, 2 decisions. It could be 3, it could be 4. But for this example, it says it's 2. So now those 2 decisions, they have events related. Those events happen because of risk. Like we said, business comes with risk, right? When you want to invest in a company, it depends on certain things like maybe the clients. In your company, that's very important. So those things determine the success or failure of your business. So those comes under events. So that is an example of a typical decision tree. So now I will be going through a very basic example which will show you what decision tree does help in order to make decisions under risk. So let's have an example. Let's say Stanley is sleeping. So Stanley is trying to do a business in USC, and there are two businesses he has in mind. And those two are a candy shop and a lemonade stand. So when he does his simple math, for example, like he said, a simple math, the income equals profit equals income minus the taxes or whatever, right? So when he does that, he finds out that he's going to make $100 if he invests in the candy business. However, on the other hand, if he invests in the lemonade stand, he's going to make $90. So with this information alone, if you guys were studying, what are you going to choose? Of course, we're going to choose candy, right? Because it has higher profit. However, that we did that without taking into consideration the events that are going to occur, right? Like I said, customers, your competitors in school, like that. So let's see what decision tree will tell us. So this is what decision tree does. So you have to introduce the events. So on the tree, you can see that it says there's a 50% chance. Okay, it's a chance. It's an if. 50% chance that you will succeed in the candy business. So if that happens, you're going to make $100, like we said before. And also, it comes with a 50% chance that you will fail, because you have other people selling candy in the school. Or maybe students won't buy a candy, something like that. So there's a 50% chance that you will fail, and you will have a negative $30, maybe you will make a loss of $30. And for the lemonade stand, same thing. There's a 50% chance that you will succeed, you will make profit, and that is the $90. And also, there's a 50% chance that you will fail and you will make a loss of $10. So from them, what are you going to choose? Using 10, right? So now we will bring in the expected value. We will use that data to solve the expected value. So then it's going to tell us which business to choose. So let's bring in the expected value. So now you can see that's the formula of expected value, like Jason already said. He explained it. You get the sum of the probability times the cash flow. So for a first lemonade candy business, your first probability is 50% times 100 plus the 50% times the negative 30. And also for the lemonade stand. So when we did that, we get a $35 expected value for the candy business and $40 expected value for the lemonade stand. So now which one are we going to choose? It looks like the candy, right? It's not candy because it has a high expected value. So first of all, expected value is like sort of income, but then it's not that you're going to make exactly $40. Maybe one day you will make 35, maybe the other day you will make 41, maybe let's say 39, stuff like that. So that is it shows you the average. So that's what decision tree does when you have, two decisions to make that comes with risk. So I think it's practically applicable for, businesses in anything. It could not be only, these two things. It could be three things and three decisions, and it could come with more than 2 or 3 events. So you just apply the same method like we did. That's what happened. So now we move on to risk as variance. So this method right here, it's about measuring risk. So risk and variance will help us to see how high the risk is involved in that business. So when you use risk as variance, I think you know what variance is, right? It's simply the square of the data and the given data minus the mean, right? Yeah, that's the variance. So as it states, the sum of the square different from the mean. Yeah, that's the variance. So we will use variance to get the risk. So the higher the variance, that means the higher the risk. So let's move on. Let's have an example. We'll have the same example. So we found out that with decision risk, it told us that the lemonade stand was the best for selling to the USA, right? So now let's see how much risk is involved in the two businesses. So now we have those data. So first of all, we don't need to table it like that. We have one side for candy, and then that is probably one column, and cash flow the other column, and also for the lemonade. So when you do that, first of all, you get the average of what the cash flow for both sides. That's the cash flow, and then you simply compute the variance. You get the variance. So that's variance of the candy. The variance is the cash flow minus the mean squared times its probability, and then you get the sum of all of those data. So we are seeing that variance for candy is 4,225, and lemonade stand is 2,500. It's clear, right? You know how to do it. So now, which one is the higher risk? This is the variance. Candy, of course. Next slide. So expected value told us that candy was suitable, right? In decent risk. Now, when we use the risk as variance to measure the risk, it does the same story. It says the candy has higher value, doesn't mean there's higher risk. So you don't want to make a decision that has higher risk, don't you? So therefore, you have to use the lemonade stand. So the two answers are agreed. However, there are scenarios where you will have the expected value should be equal for all the decisions. Now, that's when we use risk as variance. When you have same equal expected values, you move on to risk as variance, so that it will really tell you which one is the higher risk. So that was risk as variance. So now we'll move on to the QE theory. QE theory actually is a somewhat, it helps you make decisions under risk.